and we're at the Australian Space Research Conference, and I don't know how to do one of these without my laptop, so I'm just like trying to find somewhere to place the iPad. It's not going to stay.
Do you have some?
We're totally not amateurs, I swear. You could lean it up against my water bottle. Yeah, stay hydrated. Cool, no one's even watching. Oh, we have one viewer.
Hi, viewer.
So like with this foot, I could put it behind like that.
Then it will stay forward.
All right. You want that, right? Cool. Okay. Yeah. Okay. Oh, Trey Hyman. Hello, Trey Hyman. I know you. You probably have no idea what we're going to talk about, but we're at the Australian Space Research. I can't talk. I'm too excited. Australian Space Research Conference. Let me know if you can actually hear us. I know it's really loud. But anyway, let's just get into it. And if you can't hear us, we'll just like deal with that later. How do we get the chat room? All chat. Live chat.
There we go.
Alright, awesome. Now we have the chat room. So this is V. V is a medicine student. So V loves all things space and all things medicine. And we're at a 3-day conference in Adelaide, in Australia. Really cool stuff's been happening. One of my favorite things has been like molecules. It's like I thought that
I love participants in this space. Everyone's so friendly here, and I've met so many people, including yourself. Amazing. One of my favourite sessions was the Women in Space plenary, which was the first of its kind in this conference. Oh, it sounds like we're cutting out. That's okay.
This is why I need real Wi-Fi. Like, yeah. I'm so sorry. This is probably if this is terrible, I'm sorry. We're just going to keep going because I don't have any other options. If you watch TMRO or consider becoming a member, youtube.com/TMRO/join, and then we can give me better Wi-Fi to make these experiences better.
Donate today. So yesterday morning we had our first ever Women in Space panel discussion, which was incredible because there were lots of women from all different fields of science here at this space conference, and they presented on different aspects of female participation in the space industry and STEM, and it was actually quite factual. Being at a science or space conference, we're all sort of data-based, and we like that, and so that really translated into the talks that they had, and it seems that objectively females are missing out on STEM in Australia and probably the rest of it, but we are actually missing out because of stereotypes and because of differences in aptitude from a very young age. So it gives me hope that we will have more encouragement and our young STEM girls will have more opportunities to participate in things like this because they're awesome.
And I think you're a pretty good role model for that, V. You're very active on Twitter. If you check out at Vstronaut on Twitter, you will find V. Super cool Twitter feed. Highly recommend you go follow her. And as a role model for people in the space industry and as a female in the space industry, what kind of career path do you want to forge for yourself?
So I'm actually a medical student and I want to be a space doctor, and that's very aspirational, most people would say, but I have always been interested in space and scientists, but I also wanted to help people. So I started medicine and I thought, what if I can combine the two things? And so I'm trying to do that. Hopefully by the time I graduate and finish my junior doctor years, I can start doing research in space medicine and helping treat astronauts and people who are in those similar situations. I find it very fascinating, and I think it's going to be a bigger field as we go along.
I think that's really cool. I think we need space doctors. There's a place for everyone in space, medicine included, and we're going to need space doctors in the future. Sometimes I wish there was a space doctor on my space mission that I went on, but that's another story. So the topic that I watched you talk about in that session was about medicines in space. Is there anything we need to be worried about when we're going to space and we need to take medicines?
So firstly, we kind of established that diseases do happen in space and we need to be worried about them. I personally did a literature review on infectious diseases in space because not only does the space environment affect the human, it also affects the microbe. The microbe can actually get stronger at a very quick rate and become more resistant to antibiotics and other traditional ways of curing the disease. So we need to make sure that our astronauts are healthy and that our drugs work. But in order to have our drugs work, we need to figure out how they they change in space, does the radiation affect the drug? Does movement, vibration, not anti-gravity, microgravity, does that affect the drug at all? There's some evidence to say yes, and therefore we need to figure out how to make those drugs a bit more robust in space so they can last the mission without degrading and without decreasing in efficacy for our astronauts. There's nothing worse
Shout out to Eddie Cowley. We need more females in the space program. We totally agree.
I know. Thanks for engaging. But essentially what I was saying before is we need our drugs to be efficacious, and because we're going on a long duration mission, there might be an opportunity for in situ resource utilization, which is acronym ISIU. When we go to the moon, there are actually some excipients or ingredients on the moon that we can grab and use to make drugs. So we don't have to bring everything to Earth. We need to make everything as efficient as possible.
Are you saying that we could use like the lunar dust to be like the fillers and the binders for making the tablets that we use to enhance our space medicine?
Absolutely, yeah.
Shout out to Therion. I saw Therion say hello before as well. Any idea what nations or unis have you? I'm not at a university right now, so hey Loopy! Hey Jared Elvin from Norway! Is that a Tesla necklace?
Yes it is! Somebody noticed!
That's amazing. Also, can we just like take a minute to see how amazing your space dress is?
Oh, it's a dress by the way.
Every day this week V has worn a different space dress and it's amazing. So
thanks.
just like
Thanks.
bow down to the like head of space fashion. It's amazing.
There's a few different role models of space fashion here. Most of them are women. Shout out to the women. Space dresses.
Space dresses. Loopy, yeah. Maybe we could start. Could we talking about having a space fashion business?
I think not in our particular session, but I think that there is a place for self-expression through many different art forms, including clothing. We have people the fashion industry is huge on Earth, and who knows, it might be the same in space as well, because nobody wants to wear a boring suit every day. You know what I mean?
Andrew said, how do you test those medicines in space?
How do you test the medicines in space? I did a review on this as well, specifically due to radiation. So a couple of studies.
How do you test drugs like that? Do you send them on spacecraft going out on orbit, traveling outside the asteroid belt?
That is a really good question. I tried to do a literature review on how space radiation affects medications. However, there's no data yet on drugs going beyond the Van Allen belts. We've only done studies on the ISS within the Van Allen belts. They did find a slight degradation on the ISS, but we know that as soon as we go beyond the Van Allen belts, that data is going to change. We haven't got that data yet.
Loopy says it's difficult to pick out voices against the background. I'm sorry, we're trying to talk really loud, but it's really loud over here. Probably not the best conference venue, but yeah, we're trying. I'm sorry. And thank you. We really appreciate you guys tuning in, even though it's hard to see and hear. And also the internet sucks.
And the white balance is changing a lot. That's okay.
Yeah, that's fine.
I can't believe we have 26 people watching us.
Well, this is nothing. We usually have 300. It's probably because of this really bad
I'm
internet.
not Elon Musk, that's why.
Oh, no, come on. All right. Everyone in the chat room, comment if you'd rather be chatting to me or Elon, because if you want to go watch Elon, you can go and watch Everyday Astronaut.
Why not both?
Oh, exactly. Why not both? Lava lamp mode. Apart from that, it's great. It's a little hard to hear over the background shout out. Well, we still really appreciate you tuning in. You were doing a great job. Thank you, Andy. Thank you, Matt. Oh, thanks.
This is so cool.
Sorry about the beeping. So we're at a conference and the beeping's you need to get to the next session now. And we're just no, we're gonna talk to you guys.
Yeah.
So it's a lot of fun.
Friends.
Do you have an electric vehicle?
I cannot wait to have an electric vehicle. I'm going to spend my first paycheck depositing that into a savings account for an electric vehicle. I talk about it every day.
I want a Model 3. Have you ever driven one?
No.
You should.
Have you?
Yeah.
Oh my god. I've driven the Model X.
Oh, nice.
Yeah.
I like the doors.
Yeah.
This needs the doors. Model X.
Thanks, Therion.
Therion, we appreciate the stream. Thanks. We appreciate you being here. Oh man. No, I didn't realize you could actually touch the chat and scroll up. So here I am trying to remember what everyone's saying so I can read it to you, but it's right there. All right, we're new at this. Don't judge us. Okay, so electric vehicles, space fashion, and expressing yourself in space. Pharmaceuticals in space. What's another kind of topic area that you like to delve into. You did a talk on space tourism.
I did a talk on space tourism yesterday, and we know that there's lots of private companies out there trying to develop a space tourism business. So far to date, there's only been one technical space tourism company, which is Space Adventures, which collaborated with Roscosmos to send very wealthy people into space to dock with the ISS on a spare seat up. So I think each tourist had to pay between 20 and 40 million US dollars to go up. Hopefully we can decrease that cost. The one journey that will cost more than that is if you want to ride with SpaceX on their Starship.
Me, I think. Starship.
Just cough up $100 million.
Yeah.
Seriously.
Or become an artist, or if you already are an artist, work harder, I guess. Roger's really good question.
Thank you.
But yeah, what's her name? Starship. A Dear Man project. So if you're an artist, you can win a seat on Starship with Yusaka Maezawa. So. Let's get back to that question, which was me. Oh God, what am I doing? Chat room. Okay. Why does it have that? Go away. Andrew Rogers says, are you planning on using Rocket Lab launches to test medicines? Are their rockets powerful enough to be useful to you?
Well, me personally, I think there is definitely a place for private space companies to help us do our research and send payloads up into space to test them. Having said that, what we're actually interested in with space medicine is to go beyond the Van Allen belts. We've already got enough data of space radiation or medications inside the Van Allen belts on ISS, but I hope that with the Artemis program coming up, we can send more experimentations beyond that so that we can see a more accurate representation of what happens in outer space.
I think that would be really cool. And like you said, it's a place for private spaceflight. And the more rockets and more companies we have out there, the more opportunities that people like you can do cool research in space. I don't want to take all of your time. We've been here like 13 minutes. So if you want to run off, feel free to go and explore the rest of the conference, and we'll go and grab someone else to go and chat to.
Thanks everyone for listening.
This was V. Find her on Twitter, Vstronaut. She's amazing. Going to be space doctor, the first space doctor of tomorrow. Thank you for coming and talking to our people.
Vstronaut, but with scratch the A, put the VI instead. I've always wanted to say this. Like and subscribe, link in the description.
Thanks, V. Oh my God, here. Alina, welcome. Trey Harmon, thank you for tuning in. Piotr Kani, thank you as well. Matt Eddy, you're here. Matt Eddy says thank you to you, V. Everyone's saying hello. Teresa, Andrew, Loopy. Who did I miss? Scotty Harrod. Hi, Scotty Harrod. I have someone else that wants to come talk to all of you. Sorry, we have to kind of be loud because there's like weird music starting now. Of course there is. Always when I'm broadcasting. I have everyone. Jake. This is Jake Clark. You can find him on Twitter at
Space Jake. J-A-Y-K. I'm a little different.
Space Jake with a Y. What do you do, Space Jake?
So I am a PhD candidate based at the University of Southern Queensland, and I help NASA discover exoplanets. So we have a observatory only half an hour's drive down the road, and so we help to confirm exoplanetary candidates from the NASA's TESS mission.
Awesome. So you find planets, basically. You find exoplanets.
Yes. Yep.
Oh my goodness. Also, I apologize. There is a guitar thing happening right now. I'm so mad.
Also, I'm going to try it. There you go. That's better.
Should we just move? Maybe we should just move. But the algorithm, the guitars. Oh, we'll just be loud. It's fine. You know what? We're both at Science Circus. We know how to wait. You entertain the chat.
All right. Okay. I'll entertain everyone. So
we can go in here.
Okay. What? Okay.
That's an empty room. Okay. Sorry, chat room. You're gonna have to watch us as we walk. I wish I could make the chat room like stay up all the time, but it doesn't. Sorry. You see my weird face right now. Okay. We're going on an adventure. Oh, that looks ugly. Okay. Oh, look! It's quiet. I mean, it's echoey. Okay.
Are we showing this?
You can leave it open. That way people can join us if they want. Okay, so this is more quiet, but is it more worse? Hello, chat room. Where are you? Did I break the chat room? Okay, people are on the street apparently. Exoplanets! Hello, Ace Mace. Hello, Jared Head. Bingo fuel. All right.
Howdy from the States. G'day.
Yeah, sweet. Okay, we're back. Oh, much better? Oh, yay, we did it. Go team. So, you find exoplanets.
Yes,
You have an observatory that you use to do that. that.
Yeah, so
And how do you know where to point the telescopes at your observatory?
great question. Okay, so NASA's new TESS mission is an all telescope, and so that was pointing at a patch in the night sky. So if you stretch your arm all the way out, so I'm going to go back here.
Well, here we go. Let's do
Stretch all the way
demonstrations.
out, and sort of do the Cowabunga symbol, which is actually on my shirt. How cool is that?
Cowabunga.
Which is actually a Polynesian navigation technique.
Wait, what?
Back in the day.
Wait. How do you, like, you just hold your hand in the sky?
Okay, so from my pinky's a bit messed up, but the tip of your pinky outstretched to your thumb, and you outstretch your arm is about 20 degrees in the night sky.
That's
and so,
really cool.
which is awesome. So the Polynesians actually use that as a navigation tool to actually see where the stars are on the horizon, and then navigate through that way, which is pretty cool. The NASA's TESS mission was staring at a patch of the night sky, roughly about 20 degrees by 20 degrees. And so, what's great about the NASA Kepler mission is that it was observing a lot of stars. And so, it's a sort of little dip in the starlight as that planet I'm going to try. So, you guys are seeing that here, this is the star, this is the planet, as it orbits around, some of that light is going to be blocked out. And if a planet is orbiting around this star, say every 5 days, then you'll see a dip in that starlight every 5 days. And so similarly with TESS, it's looking at a larger patch of the night sky. It's looking at about 85 to 90% of the entire sky for planets. And so it detects a signal which could potentially be a planet-like signal. And then so it slices the two hemispheres up into 13 sectors. And then each sector, they'll detect exoplanetary candidates, and then they'll send it to follow-up teams like ours, like me, as a part of the Minerva Australis team, and then we'll go and confirm and make sure that they are planets or another star orbiting around that bigger star.
Oh, so you can get like false signals, like, so this.
That's right. So it can potentially be another star orbiting around that star. It can be the likes of star spots and stellar activity as well. So if you have a large sunspot, which is a spot on the stellar surface which is a little bit cooler, and as a result is a lot darker on that star, and if it rotates and if it has a long lifetime on the period of, say, some sunspots here on the sun even can have lifetimes of weeks, maybe months. And so the planets that we do find have incredibly short orbits on the order of days, in some cases hours, which is absolutely wild. And so you want to be careful and make sure that this is indeed a planet and not any sort of type of activity.
So if it was a sunspot, I'm guessing then that the signal is kind of just, oh, you have a sunspot and it's gone, so you get like one dip in brightness, but like it doesn't repeat. Is that a telltale sign?
Yes and no. So it could potentially be that it is a sunspot and it decays over time. So what could potentially happen is that as it rotates around, as the sunspot decays, it will get a little bit smaller, and so that dip will become less and less over time. And you can actually see that star spot evolve and decay. And if you see one single transit, then that tells you, for example, if you've been looking at that star for 100 days, and at the start of that mission lifetime of 100 days, you see a transit, and then you never see another one for the rest of those 100 days. Now that could potentially tell you that there is a planet orbiting around that star that has a period longer than 100 days. Or it could just cross that star and then decay, and then as it came across, as that stellar surface rotated back again, that sunspot completely decayed and wasn't there anymore.
Wow. We had a question here from, sorry, I'm so bad at using this iPad. Andrew Rogers wants to know, which new instrument are you looking forward to coming online in the next few years? If you ignore JWST.
The JWST. Now that is, I'm not laughing.
I mean, when it launches, right?
When it launches.
Lucy says, is the chat room working? It is working. There just wasn't, no one was talking, unless I have this set to not all chat. Like a live chat. I am doing live chat. I do sometimes know what I'm doing. No, I don't.
So I am definitely looking forward to JWST when
gets up online. I was very fortunate enough to be in the States last month and was able to get to the Space Telescope Science Institute based in Baltimore. And so that's where the Hubble's headquarters are, and will indeed be the headquarters for JWST. So JWST will be able to find and detect the habitable. So I'm really looking forward to that. I mean, JWST is huge. It's the largest telescope ever to be created.
What if it doesn't unfold correctly? What happens then?
I think, I mean, a lot of the delays, and I mean, there's a lot of complaint about delays, but you forget about the delays when you play that game. You think, oh my god, this is absolutely amazing. This is the best sort of game ever made. And so, similarly with JWST, it has been delayed by almost a decade now. It's one of the most expensive missions ever to be conceived, but the actual science that will get out of JWST is going to be absolutely incredible. Now, JWST is looking in the optical and in the infrared. And so what's great about the infrared is that as the universe is expanding, the far-reaching galaxies that we can't see at the moment due to the optical light that it was emitted has actually been stretched out due to the expansion of space itself. So all of that light is now in the infrared because of the wavelength that's actually being stretched, just like a slinky as you extend that slinky out. And so with JWST, we're going to see galaxies that we've never seen before. You're going to see them as they were maybe 100 million years, or maybe tens of millions of years after the Big Bang itself.
Oh man, you're so excited for it, and I love that you like compare it to Ghost. Oh no! His stream is just like suffering intently. Oh my goodness, everyone's just talking about how like they lost the video, but now they're back. You know, we just keep going here at TMRO. You know, our cameras fall over, we lose Wi-Fi, there's a band playing in the background.
And that's sadly for you.
We're going to go for like 5 more minutes because I do have to let Jake go. But please ask questions of Jake because you're really passionate about what you do. How did you get into space?
Very good question. I think as a kid, I've just never stopped asking why. And for me, space, I can't remember what it was, but I just latched onto it. And there's not a single moment there where I can think that that was the point that got me into space. But the likes of Dr. Andy Thomas coming from Adelaide, so this is my hometown actually.
Which, by the way, you had a photo with Andy Thomas for the first time Monday.
Yes, which photo credit to Lisa here. So thank you for that. And so I would wake my parents up at 2-3 o'clock in the morning. And so I grew up in a rough neighborhood. And so you can imagine waking up your father at 2-3 o'clock in the morning, looking at me like that, these beady eyes staring at him, and go, what, like almost having a massive freak out. Like, I just want to go outside to wave at Andy.
That's amazing.
Oh, all right then. So pulls me outside, and we see the International Space Station fly over, and 6-7-year-old Jake with a big cheesy grin waving at Andy as he flies by. And so I always wanted
I'm sure he waves back.
Yeah, I'm sure. And so I've always had a passion to be an astronaut. I mean, as most kids do. But I was like, no, this is me. This is what I do. Turns out I'm 6'4", and I'm actually too tall to be a pilot in most situations, and therefore too tall to be an astronaut.
I have the opposite problem.
Yeah. Well, here we're basically down, so we're on the equal playing field. But,
Exactly.
Yeah, so I thought instead of being an astronaut and being out there in space, I can be on the ground safely and look at the heavens from this perspective.
With all the comforts of indoor plumbing. So we have one last question here before I'll let you go. Therion, are there any ideas for CubeSats continuously monitoring individual stars? I've only heard about PixSat, which was already looking for transits of a Hill sphere, you probably know what that is, I know, around Beta Pictoris b. So basically, in a nutshell, CubeSats looking at stars to find planets and all.
Alright, I'm going to go out there and I'm going to say that I have zero knowledge on CubeSats. So my knowledge is heavily based upon astronomy and astronomical sciences framework, and not a great deal on space research. So I can't really talk a bit about CubeSats, but TESS, for example, is looking at that patch in the night sky for 27 days straight. And so what's great is that there's no day, there's no night, it's just space. And so you're constant, and so there's stars that are being observed every 30 minutes.
Yeah.
There are some stars in very special circumstances that are being observed every 2 minutes. And so you can see the brightness change of those stars every 2 minutes if you want to. So, and that data is publicly available, and there are public tools available as well to utilize that. So if you have a favorite star that has potentially been observed by TESS. So TESS doesn't look at what's known as the ecliptic plane, and so the ecliptic plane is essentially where the sun travels across in the sky for very obvious reasons. And so if it's not within the ecliptic plane and it's in the southern sky, the northern sky is a bit iffy due to there's a lot of scatter of moonlight and earth light. So they've actually had to push up the sectors up and had to do some jiggery-pokery to get that to work. But if there's a star in the southern sky which you like and you think, oh, there might be a Hill sphere around, so these Hill spheres are theoretical constructs where alien civilizations...
Oh, like a Dyson sphere?
Yeah.
Oh, okay. No,
Is that right?
I don't know what a Hill sphere is. I've heard of Dyson sphere.
Because a Hill sphere, my interpretation of a Hill sphere is actually the gravitational influence of a body. And so if you get within that Hill sphere, then it breaks up. Yeah, sorry, so I completely I was thinking about two different things.
It's been a long time.
Yeah, it has.
Guys.
Sorry.
Like, it's literally been like 10 hours a day of sitting in speeches and presentations for like the last 3 days.
So my brain's like a little right now.
Yeah. Yeah, well, it's 30 minutes, and I don't want to take all your time, so if you...
I'm happy to chat as long as you want.
Really?
As long as people are happy.
Oh, alright. Well, very quick, everyone, get your questions in. So last time we did a stream like this, we were together, me and whoever was watching, we were doing Planet Hunters on Zooniverse, where you actually look for transits and some data from TESS.
Yeah.
And so what I think happens is that me and other citizens identify some data that might be interesting to look at for the researchers, and then I guess that gets pushed to people like you who go and observe those stars and try to improve them.
Yeah, so the sort of signatures that we think could potentially be an exoplanet have either, so there's a lot of data that's gone through a certain pipeline, and obviously being machine learning algorithm, there's all sorts of generalizations that you make, and so actually having human eyes on said data is also very beneficial for numerous reasons, which I won't go into right now. And so through those pipelines they go, okay, well we think that we've found a planet-like signal, and so those signals are known as planetary candidates, and so for TESS, it's TESS objects of TESS objects of interest. Yeah, that's right, TOIs. And so the likes of planet hunters, for people like yourself and anyone here listening, you can go on the likes of planet hunters and Zooniverse and all the rest of those great citizen science projects, and try and find transits. And then those actually go through community TESS objects of interest called CTOIs.
Cool.
And so, as a follow-up group that I'm a part of, Minerva Strauss, we go through both TOIs and CTOIs, and so we can confirm both and make sure that they are indeed exoplanets. So we haven't yet discovered an exoplanet that we can claim directly as our own. We have helped to contribute to numerous planets so far. There's 2 systems that have been published so far with TESS, and we've got about another 10 through the peer review pipeline right now.
Awesome.
One planetary system in particular, which is hugely exciting, which I cannot talk about right now.
We'll get you back on in the future, it's fine.
I will be shot down and you will find
You
me
talk
floating
about
in
it, and then you
comments.
would just have the string cut, and everybody would just think it's the internet because that's my life right now.
That's right. Is that the comments?
There was someone from the conference venue, like one of the like janitorial staff, literally he's walking towards the door, sees me, and goes like, I don't know if I can demonstrate it, but they were like walking, they were like, what? And then just walked back out. It was hilarious. You didn't see them. You didn't see them, but it was funny.
But yeah, I'm really excited and watch this space.
Hello, Marty. Loopy's going. Good night, Loopy. But there's a question here from Andrew Rogers. How has the Australian Space Program made any impact? Do they have a presence at the conference? And I think they mean agency sort of program.
Yeah, so the Australian Space Agency has a huge presence at this conference. The head, Megan Clark, and the deputy director, oh man, I'm terrible with names, good with faces.
Anthony Murphy.
Yes, thank you. Thank you for saving my bacon right there. So he was there. There's also the SA Prime Minister, SA Premier, Stephen Marshall was here, and there's a huge buzz that, honestly, as an Australian, I've never seen
Me
before.
either. This is new. Like, this conference has been so lit.
Yeah, and there's just a huge buzz and excitement, and I mean, in particular, I've been thinking a lot about asteroid mining.
That's big here too. There's a whole session to it. Marty, yes, we are in Adelaide. Oh, we should have had a tomorrow meetup because aren't you in Adelaide or Brisbane? I forget. I don't remember.
Yeah, so there's, like you said, a whole session on asteroid mining, and if you had an asteroid mining session here at the Space Research Conference even 2-3 years ago, people would be like, look at these losers. Where now, people are actually taking it quite seriously, and there's now research groups actually seriously considering the prospect of prospecting asteroids.
See what you did there. There's always plenty of puns on this show.
Really cool. So yeah, definitely a huge presence with the Australian Space Agency, and last week with the announcement of $150 million helping Australians assist with NASA's Artemis mission, which is going to be huge.
I'm excited for that. A lot of people were like, Australia's giving money to NASA, $150 million, but like that's not what's happening. That it's going to Australian companies to be able to participate in the Artemis program. So wherever there's kind of gaps that NASA needs to fill with Artemis, if Australian companies can fill those gaps, they're going to collaborate and get that done.
And so that means that that money is staying in Australia.
Yeah.
Right? We're not just sending off to America. Bye. Here's $150 million. Like, this is actually
Like
helping
that,
us.
to be fair, $150 million wouldn't even really make a dent in NASA's budget as it is. Like it's not a lot of money for NASA.
And I mean, the economical benefits of space research is huge.
Mm-hmm.
So NASA, there was a study that suggested that for every dollar the American taxpayer puts into NASA, they actually put out roughly $5 to $15 back out to the American economy. And so it's all of the technology that NASA creates and develops that private companies wouldn't, because it's just such a high risk that the private companies just wouldn't invest in that. And so NASA then develops that where private companies go, oh wow, that's actually quite fascinating. Let's grab that and let's start to make something of it. And so that's how that sort of festers through the American economy. So.
Besides, we're going to go pretty quick here because the next session is starting now at 4:30. Besides the asteroid mining stuff, what else has been what is your number one kind of takeaway from this conference? The thing that you either listened to or saw that you're absolutely super excited about and can't wait for it to happen?
I think just the development in medical science and medical physics in terms of space flight and getting people safely from Earth to Mars. I mean, there's a huge buzz and excitement, and Elon Musk is really driving home the point that, yeah, we're going to get there in 2025 and everything's going to be awesome, but there's a lot more research to be done in terms of the effects of zero gravity on a human, there's a lot of talk actually about medicine and actually making medicines in space, and just things that you don't even think about.
This is hilarious. You missed it, but we're talking to V at the start here, these two not, and that's what we talked about at the start of this broadcast. So it's a couple of circles.
We've actually come full circle. So that's what I've enjoyed about it, for sure.
Me too. That was one of my favorite things. I was telling everyone here. The group that was looking at using lunar dust as like the filler material for like tablets and pills in space. Yeah, awesome. Well, on that note, let's go to the next session. Thank you for joining us, everybody.
Thank you so much for having me.
Where can they find you if people want to find out more information on your work?
So you'll find me at Twitter, SpaceJake, Jayk. You can find me if you just Google up Jake Clark USQ. You'll find I've done some conversation articles. I've written up about a dozen or so conversation articles. And yeah, I'm trying to work on a personal website right now. So yeah, watch this space.
Awesome. All right. Thank you everyone for joining us.
Bye.
I have to figure out how to turn this off. I don't know what I'm doing. Oh god.